I would go standard, or like use the top of Google, the top.
All right, I'll
clicked images or anything.
go ahead and get started here. My name is Varian. I've come here a couple of years. I don't like public speaking, but that's why I signed up to be here. It's a great thing to do, and the other thing is it's great to teach folks things you've learned. So you can find the PowerPoint slides here, as well as that board we can give away for if people want to put together. The instructions are there. A little bit about me. So I went to school for electrical engineering, which did not teach me about designing boards. It was 10 years after leaving school before I did the first PCB. And since then, I've done a lot. And it's sometimes like you can do super simple. Sometimes a PCB is nothing more than this connector to this connector, and that's it. And so it's useful because it saves a lot of time and when you do things at scale. So PCBs are great, and it's also a thing of it's a really cheap way to, or it's cheap to do now. So you can do it, you'll fail, you'll make other mistakes. What I'm giving out today, it's got mistakes. But most of the time, even the failed ones can work. So another thing is, if you have questions along the way, please interrupt me. I can talk really fast and catch up. So if you have questions, just speak up. Let's see. PCBs are basically, they make connections in a fixed way, and so let's see. You have temporary like breadboards. You can hook point A to point B, and it's good. But you can also make these PCBs where you can make them at scale and make a lot of connections. And so one of the reasons to make PCBs is they're a lot more rugged. So these two boxes both do the same thing. I do some work at a bomb range, basically. And so this is connects to a high-speed camera, and it triggers on like an input signal to turn on the high-speed camera. And this one on the left is what they use for years, and it works sometimes. Like you can see, it's a first board, there's solder things, there's wires sort of just floating out there, and it doesn't hold up over time. So making a PCB, same connection, same circuit, same parts, but it's a lot more rugged. Like all these wires are no longer floating out there. You have stuff that's fixed better, like see here, you have like screws here versus this is like sort of held in by one edge, and so you can make things that connect to the environment a little bit better. Software I'll be showing today, and I'll be going back and forth between the slides and the software because it's tough to capture some of this stuff without sort of showing. I've been using KiCad. There's some other ones that are free, like Easy EDA is another easy enough one to learn. I think Eagle you can get it on like a hobbyist license. Altium, there's a version that's free. They all do the same thing. They can all do the same thing, especially for hobbyist type stuff. Let's see here. So there's some steps you'll take along the way. First, you have to figure out what you want to make, and that sort of, it comes down to figuring out, okay, what parts are going into it, what form factor does it fit, all this type of thing. Then you have to figure out the circuit. So like, okay, this resistor, this kind of current, all these type of things. Then you have to go and actually find, okay, the resistor can come in 25,000 different packages. Which one do I want? Then you go to, see, footprint design, which is, okay, I chose package 12. That's this size, these holes with this spacing, and it's not, and so it's easy to sort of mess that up. So you decide, you have to figure out this is what that looks like in the real world. Because a schematic is like a logical thing, the real world is that footprint. Then you have the board shape, like this is a weird sort of L-shaped type of thing. It's not all PCBs have to be square. And then finally, you have the sort of the layout of where all those parts are going to sit in the real world on that board that you've designed the shape of. And then finally, you export something called a Gerber, and that's sort of the standardized files that people use to make something. And then you can go through the process of actually going and ordering the thing. So starting off for this, I got accepted to do a talk as well. I have to make something to at least point at. So it's like, well, it'd be kind of cool to do one of these sort of soldering challenges things. It's hard to get a sense of scale. This is the size of maybe a quarter. So I thought, oh, that'd be kind of cool, but that's a tough one. So I was like, well, we need everyone to be able to do it. So I wanted something a little easier, but also got down to some of these harder ones. And then I was like, well, it has to also be sort of fun. So last year I was here with Biggie, and oh no, we can fix this.
You should talk to Tyler about how to make slides better.
I should. This is most impressive. All right. So our room. Look at this.
You will be hearing from my lawyer.
So it had a flashing light. I thought, well, this was a funny video that he made a mistake posting where I could get to it. And so this year's PCB badge is. And so let me pause this real quick. With the kids that are going around in that box, and at the end they'll be back here by the soldering stuff. And if there's any extras, you have any aspirations to do multiple, I'm sure there's probably plenty there.
About 60 left.
Oh, yeah. So even if you don't want to, take 2.
Stocking stuffers.
Yeah. So the kind of neat thing about this is anyone can do get the flashing light up here, the push the button. That's a very easy soldering thing. I think there's some folks back there to help you learn if you've never done it. And then if you want to sort of go up to the next steps, there's some very challenging ones here. This little light here is the size of the ball and a ballpoint pen. So it's not easy, but it's also doable. I think you had someone do it already.
I know how to do it.
Yep. So.
Took her 3 hours.
And we'll try to set up some stuff, make it a little easier later on tonight. All right, so next we have like how do you, got all this weird stuff up here, but we'll leave that up there. How do you design your circuit, which is you have to figure out what parts you're going to use, what connects to what, any other things that, they're not necessarily parts, but you have to take account for. Like there's the image on the front of that, that's a part in that it goes on there, so you have to sort of account for that as well. Next, there's the simulator, which is something that unfortunately, well, I think we skip a lot more than we should because there's a lot of things that if you spend the time to do that, it shows. So, and there's some pretty cool resources. Every circuit here is a simulator. So basically, this is the badge that you guys all have in your hand. And so, the switch is down. You get current. You can see, okay, this resistor size will work. This LED work, this battery, and so it's pretty easy to go and find some tools to simulate these circuits. So you don't have to necessarily breadboard them out, although that's great if you have the parts in. A lot of times you sort of do it all at once, you don't have the parts on hand, so at least getting yourself a good idea. And then again, breadboard, if you have all the parts, it's great because it's the real thing and you can know, okay, this connected to this will work. And then component selection. So at this point, like you have your resistor and your LED, and a resistor and an LED take many short forms. And the other thing is, you don't necessarily need to pick at that moment. Like if, let's see here, like I can make a board and I know it has an LED and a resistor. I don't need to know what the resistor is just yet, because the size of it we're going to define, and there will be 1,000 values you can buy. So as long as it fits in the right size, you're good. But part of picking those components is sort of narrowing down some of these requirements of, okay, it has to have this type of value and this type of form factor. And so there's a couple of websites, DigiKey, Mauser, LCSC is like the Chinese one. It is pretty cheap, but the big thing is you want to make sure you note the length and width, footprint size, these type of things, because nothing, I'll have it here in bold because this is the case, all the error is pretty much in this step. Like the board you have there, there's instructions to build it, and the first instruction is the battery. If you look in the back, there's like actually, I'll get to it, but there's a circle and a little bar, that's backwards. So if you put the battery in like it looks like it should fit, it's not gonna work. And so, and that is because, then sit there and double check, pin 1 is what I think pin 1 is. And so that's sort of, and I think Tyler agrees, like this is where almost all the PCBs fall apart.
Every transistor.
Yeah.
1, 2, 3,
Yeah.
3, 2, 1.
Yeah, and the other thing is sometimes like there will be packages that everyone uses this form factor, so like resistor arrays are bad about this. Like you'll have this size of the resistor array, one person measures it this way and the other one measures it this way, and so you can find some weird weird ones where it's just, if you don't spend the time and make sure that you are getting what you think, you'll end up with pads and wrong spots. So, schematic creation. So once you've done the simulation, sort of have your parts picked out, this is where you go and you'll do make your schematic. And what that is just real quick, this is KiCad. Like, you turn it on and you get these options. So this first one here is schematic editor. You click on that and you'll end up here. And this is sort of the logical level of what your circuit's doing. So right here, like this is that blinking LED. These are the small ones, and I'm sorry, these are the LEDs. Push all the wrong buttons. And then you have your small ones. You have your push button here, your battery, and so at this point you're laying out the circuit, saying, okay, this is what I want to eventually connect to this. This is how I want it to be laid out. Just a logical level, because right now we don't know any of these parts. We just know that's an LED. And then once we've done this, and we do some math and say, okay, this is the resistors I need. This is for these types of LEDs. Up here, I talked about like the graphic there. I call it a test point, and it's not a test point. It's, let's see. Click the right. There we go. It is. It's this little thing here, which is a picture of Dickie, basically. So, because I need to somehow still capture that here in the schematic, because we're going to pull that forward into the board design. So, once we've done that, we then have to go through and say, okay, this resistor, what is that? And you go in, and that resistor is just a placeholder, so you have to say what that footprint ties to. You don't necessarily need to tell it the value. Like, it doesn't care. That's more of just for your informational. What it cares about is this here, which is the footprint, which is showing, okay, it's going to be, what is this, a 6.3 millimeter by 2.5 millimeter resistor. THT, you'll see, that's through hole. Sometimes you see, then we'll go over here to one of these, and this is SMD. That's one of those small surface mount ones. And so basically, you go through for every part and to say, okay, this is what I want this part to be in the real world. Like, okay, this is a push button, this size. And so once you've done all that, we'll come back over here. So now we've created the whole, this is connection A to B, this is our footprints for everything, and then we'll go on to sort of defining footprints. And sort of for sake of time / getting into too much of the weeds, I'm not going to go and make one of these, but there's huge libraries, and normally you just Google and download one. But also, most everything's going to fall pretty much into something already made. Like if you have to make your own footprint, it's not hard, but it's also not very common. So, like I said, a lot of times, like that. Go back. The biggest of the SMD LEDs there is this 1206, or you'll see like SMD 23 transistors or something. And there's a lot of things where you'll sort of have to find, okay, this is the component I'm buying, and then make sure you have the right footprint for it. Real quick, just sort of before we get into the layout of PCBs, how they're made up. It's normally the substrate is normally FR4, which is like a fiberglass type of thing. Then it's bounded, and for like a double sided, this is I guess sort of a one layer thing, but you can imagine on both sides. You have copper, and then above that you have a solder mask, and then silk screen on top, which is that white text you see, you like the image, is that silk screen. So, board shape, again, this doesn't, some of this you can do later, but this sort of decides your board shape, and I like to do it just because it gives you the bounds of like, here's the area you have to work with and understand where things are going to go. It's also good at this point to put like, I know I'm going to put a hole here, so go ahead and put a hole there at this point. So this part's a little bit more intimidating when you first start because there's a bunch of colors and lines. It doesn't really make sense. But the so this right here, this color shall be, where are we at here? Edge cut layer. So this, anything on this edge cut layer is going to say to the board manufacturer, cut this out. And so here's where we did the board outline. It's also where little holes made here. And then you'll go and you'll drop in a part, and real quick, like go ahead and mess everything up live because it makes for good demos. So let's say we wanted to put this over here instead. So when you first drop everything in, you won't have all these blue and red lines. You'll just have a bunch of components connected with these thin wires. And those are saying, I need to get to here eventually, so make sure that that circuit gets completed. So you'll put it where you want, and we'll say here. And so here we can say, let's see, here, click on the wire, I'll say, you want this pad, and I need to get to over here, and I can click there, etc. So you'll go through and you'll basically place all your points, and then you'll tie them back to the parts they need to talk to. There's some sort of, anything on it, most everyone's just going to start doing like 2-layer boards, and that's this red stuff. So anything red is on the top of the board, anything blue is on the bottom of it. So to get between them, you have these things called vias. Vias are basically a hole through the board that's plated, and so it connects the top layer to the bottom layer. So if you're doing this, you want a via, basically you can hit, well, let me go back and get rid of these again. Let me click the right tool. All right, so we want to make that connection, and so we'll go back to that wire tool. I'm going to still go over here, and if you hit V, it creates a via, and so you don't necessarily have to do it like right on top there, but you put it wherever, and then it switches sides, and you can then finish that connection. You wouldn't want this because it's pretty ugly, but you're getting the idea of you're basically making all these connections as you go, both for basically every component on there. So earlier, talked about like we did that test point, and that's to have this image. And the KiCad well, none of the EDA stuff does images great. It's always like some weird format. The easiest way I found it is to make it think it's a part, and so it thinks it's a footprint. And so you can certainly convert images, and there's even this image convert, and it does a pretty good job of it. You put in an image and you tell it what you want out, and it does okay. So once you've done all this, you have all these done. Okay, so we've connected all the points. We have the image in the right spot, the outline of the board done, and so now it's on to Gerber creation. What Gerbers are is basically over here. You have all these layers here, and these layers they mean different things. So like this BCU is the bottom copper layer. So anything you see going away there, that's what's going to be copper on the bottom layer at the end. Same with the red top layer copper. You have like the silk screen is that stuff on the top, this bottom silk screen is the silk screen on the bottom. So you have all this stuff, and so basically you need to come up with a format that people know how to read. So for KiCad, you come up here to format fabrication outputs, and you hit Gerber, and you have a bunch of options. I think, because I just installed on this computer, the defaults work. There are certain board houses that want certain settings, so sometimes you have to go and like read what they're expecting and change your settings here, but most of the time it's all pretty standard, especially simple stuff. There's a huge array of like complex stuff, but anything hobbyist type of stuff, it's super easy. So at the end, you basically export a file that comes out to be a Gerber, which is a folder with a bunch of, basically a file for every layer here. And then you zip that up, and yeah, so you zip it up, and you go to some board house to get your board made. And of course, you can make them yourself, but I want to do 100, right? And so, it's a huge process making boards, and so because it's a mass production thing, and the way they've gotten it down, it's real cheap. So I've made 100 of these boards you guys have here, 17 cents a piece, I think. So it's yeah, and like I mean, if you look, it's 17 bucks for them and 25 to get them here. Like most of mine is just in shipping. So, but what you'll do is you'll upload them. You'll get a couple of options. This is looks like JLC's site. You can choose normal material, flexible boards, and so the flexible aluminum, copper stuff, those are neat, and I've done those, but it's also a little bit, one, they're more expensive, but it's also pretty niche. The layers, if you had just, so instead of saying we had, so we could have made this board routing everything on the top layer. We could have done a one layer board. We have the back layer there, so we're going to do two. 4 would be 2 layers in between, which is also not all that expensive, but let's see. And then, you choose the quantity. You say, okay, I have 1 PCB. You can choose thicknesses. They're not a wide variety, but there's a difference. And you can choose colors, surface finish, but you already messed up. So, like I said, if you see here, this little tab was supposed to be over here. Because I did not sit here and check, actually, here we go. Basically, what you would have to check is like, on this battery, there we go. So pin number 1 is positive. Then over here, I have this as being positive. In reality, and I didn't have the battery holder at the time, so couldn't really confirm it, but the positive is the other pin. Works out okay for this because they're still symmetrical, you can swap it around, but stuff like that's why you really, it's really important to check the footprints, because again, that's almost every time I've messed up on boards, it's been just footprint mismatches. All right, then, let's see, that's pretty much all I have. I have a study here for those interested in doing the board.
What's your problem? It's the fruit on the side of your left.
That's it. So if you are interested in doing it, there's another video of Dickie here.
Dickie!
And so there's sort of some pictures to give you an idea of mainly the LEDs are the sort of tough ones, because you can put these on either way, the resistors, it'll be fine. LEDs, you can put them on backwards, they're not going to work. And they're small, like I said, this is about the size of a ballpoint pen. But the through-hole stuff, anyone here will be able to do. Again, you put the LEDs in. There are a lot of best practices that I did not do, such as marking like components here. This normally you'd have a resistor value, or at least a resistor number that corresponds to a value. Same with these. The way I got away with it was by just making everything different sizes. Like you can't put it together wrong.
Every talk should have a I should have.
You all now have a challenge.
But
I'll make one emit smoke. I'll take video.
all right. So are there questions? I have, I'm sure, tons of time.
One question.
Go for it.
That software, the KiCad?
Yep.
You manually place every single component.
Yep.
Is there an auto layout? Because I'm lazy.
There's auto route. I don't think there's auto layout.
I think you can hook it up to like a third party.
Yeah. So because we have plenty of time and I can make things look bad here, let's do that. Where's the bottom of the form? Let's see here. Changes. So what I'm going to do is, why not?
You don't have anything to hit. You don't want to hit save.
Well, I wanted just to do a new one. Can you not just, here, I should do this.
There you go.
All right, so here we've got rid of all that. Come over here, you'll still do all your schematic stuff. You'll say, okay, I'm ready for the PCB. And you'll come over here and where are we at? Pull in changes, say update PCB, and this is, anytime you change the schematic editor, like anything in the schematic, you have to change it in the PCB and pull up any changes, because things like the footprints and all that have changed. But here's what you start with. Like you don't have a board outline, you don't have anything, so you have to say, okay, well, say you want to do the board outline first. You do that, you'll do your we'll say a rectangle. Like, okay, this is our board outline now. That's where we're gonna have the board. And then we'll come over and say, okay, we'll put the battery here, put all these wherever they might go. But yes, it's still a very manual process of you defining where things go. There is, I think there's an auto route. I've never really used it, but we'll see. Maybe not. Is that a plugin?
I don't remember. I've not.
Yeah,
I don't trust it.
Yeah, so none of the auto routes really always work all that great, so I normally avoid them. But basically what you'll do at this point is you'll have, let's say, you have your parts, spray some more. Okay. And then you'll come over to this is the wire thing, and this is obviously very top level stuff because, so that connection there is fine, but what if you wanted this wire to be thicker? You'd have to go and change settings, but you can make that, you can make it thicker, right? So you can do that type of thing. One thing I don't have on this board, but it's actually really pretty common, is to do these, they're called copper pores, or like fill zones. So what you'll do is like, you'll say all this, is normally, and so, back out of, let's see, so I'm going to define this little layer here, and what you can do is you can say that anything inside of here is filled with copper, and so you can just say this is all ground plane. So a lot of times when you have like a good sized board, you'll put this on a whole layer, say everything here is ground, and then we'll make exceptions. And so I can then run wires, like if I wanted to route. If I wanted to route up there, like right now it's covered in copper, but you'll rerun it and it'll actually take away the copper around the route you're doing, because you still want your signals not to be affected, but you can say anything in here is still ground. But no, to answer your question, it's not a quick like drop it here. There is some automated stuff, like you can select things and like arrange them in a rectangle or a circle. Those are some options, but it's still a very manual process.
For the argument.
Yep.
Drew your picture.
I did.
Do you have to pay royalties to Dickie?
Every time someone pushes the button.
All right, you know what to do.
Push Dickie's button.
The first round's on me.
Yeah.
Could you show your QR code again? Yeah.
I can.
QR code.
It is. There you go.
How long did this take to make? How much of that time was spent looking at a picture of me? And would you recommend that? Can you speak to this?
An hour, 12 hours, yes.
Yeah, just go ahead.
Any other questions?
Why does this blink?
So that's a really good question, because LEDs should not blink like this one does. So
Or like the hotel.
if you hold this, like the blinking shouldn't happen as far as a normal circuit. The reason this does is this is not a true LED. It's an LED with a small circuit inside of it that makes it blink at a certain rate. So if you get maybe a magnifying glass or microscope and look real close, there'll be the normal LED sort of. It's normally a triangle and a little ledge, and then there's a little tiny chip that is in there soldered on top of it that is actually controlling it blinking.
Yeah.
Yeah.
The www on that is required.
I'm not sure what we're saying here.
He said the www on that URL is required, which I can confirm.
Well, it doesn't require it here, but I don't doubt you. I'm just.
But I do.
Okay.
Counter example. Here we go.
Any other questions? Well, if you guys want to put it, go ahead.
When you order the boards, does that come with components and all
Nope, the board, you can order the boards, and you can order the boards being assembled. It's a little more sort of legwork, because you have to say, okay, this slot is this component, I want to buy from this source, but you can certainly do that, and it's not a bad route, especially if you have something like pretty complex or a lot of something. Assembly, especially overseas, is not all that expensive. And so if you don't want to make a lot of something, it's not a bad route, but it doesn't normally come that way. Normally, you buy parts from your parts supplier, boards from your board supplier.
No, Doug?
Yes.
I wanted to ask you if you could show the surface mount transistor outline just for the purpose of my warning to everyone. Surface mount, three terminal surface mount.
Like SI-23.
Okay.
Let's
Just a quick break.
see.
If you go to the PCB editor, it's like a,
I'm sorry, this was.
Can you just change the?
I wouldn't know how to do it. Thank you.
Can I guess I could assign a footprint in.
Any filter? Just SMT.
something.
Yeah. Transformer.
I think this standard one is just like.
What I wanted to point out is that the transistor has 3 terminals. It can be a positive, negative, positive, or negative, positive, negative. There it is. Oh, not a circuit, not that kind of stuff. SOT. All right. Anyway, the most common mistake that I have made, and other printed circuit board designers have made, is that they will be using a lot of transistors that have that same footprint. The 3, and I'm holding my fingers like this, that's the 3 legs. But they aren't emitter, collector. That's it.
There you go.
That's it. Go back to the footprint.
Yeah, 1 second.
So I'm sorry. Thank you very much. Thank you again. Thank you for this presentation. That the 3 pins are not the same between all transistors. You would think that the manufacturers would make them all the same. They are that exact same shape, but they are not the same. And you might have 10 different transistors on your circuit board, and the electronic designer designed those transistors to be full because of their properties, because of their electrical properties. But that doesn't mean that they're connected. So you cannot assume, and there are many ways to go along with that. Sometimes you can get away, if you screwed up, you could put the transistor in at 120 degree angle and make the lead still reach. But they're not perfect. They're not perfectly touching. But you can sometimes switch them. But it is a very common mistake, and that's why, as the saying goes in the industry, nobody runs with a Rev 1 board. If you do, really simple, even when it's very simple board, you don't run with that. And I thank you very much for your presentation.
If you guys want to work on the boards, there's some tires I'll set up there, and or find Warren. He has a bunch of soldering stuff and can help you get going if you've never soldered before. But thank you guys.